Hello, hello. Another day of notes. Today we are going to be talking about similar polygons, and I told you we are going to be using the ratios and proportions in this, and we are. So, we've talked about congruency before, but we have not talked about similarity. So, we're going to go ahead and talk about the difference between those two. Start with the definition of congruent. Okay, congruent. We show that by either using the two squiggly equal signs or the equal sign with the squiggly on top of it. That means congruent, in case you didn't know. That's what those squigglies mean. And what congruent means is same in size and shape. Okay? So, two things are the exact same size and the exact same shape. They are basically the same figure. But similar is different. If they're similar, they're different. And the thing we do that is just one squiggly line. Okay, one squiggly line. And that is going to be important. For similar, the shapes are going to be same in shape. They have the same shape, but not the same size. Same in shape, but not in size. Okay, so let's say we have a tiny little rectangle or square or something here, and a bigger one here. They're the same exact shape, same proportions and everything, but not the same size. Okay, you can leave those there if you want, but I just was doing that to show you. Got a little bit more to write here. And this is basically, I don't know what just happened there. Basically, a figure is changed by, and this is I think it was Nathan, shout out to Nathan, or Kylan, I don't remember who said that when we were talking about transformations, we got reflection and all that stuff, but dilation. Dilation was not one that we talked about. Well, now it is. A figure is changed by dilation, which just means it gets bigger and smaller. So you got like I said, you got a small little rectangle and then you got a big little rectangle. They're same exact shape, but different size. These two are similar. So make a little squiggly line in between. Those are similar. So we're just going to go ahead and get started. First, I need to tell you how to write everything out because, you know, geometry is very particular. So let's say we just have some kind of funky shape. Okay. And this is going to be A, B, C, D. It is important that you put these letters in the right spot. Then we have another one here. A little smaller one. I just made some random shape. And this is W, X, Y, Z. And we have some measurements. So let's do the first one, the bigger one. AB is 15. BC is 12. CD is 21. And DA is 18. Then the littler one, WX is 5. XY is 4. YZ is 7. And WZ is 6. All right, so I'm just going to teach you how to say these things are similar, all this different stuff. The first thing we're going to write is something called a similarity statement. And we're kind of familiar with this from congruence. Basically, if you say quadrilateral A, B, C, D is similar to, and you know it has to be in the same exact order. So A is similar to W. B is similar to X. C is similar to Y. D is similar to Z. Same thing. Remember how I talk about you start at one point and you go around in a circle? Same thing here. Start over here, go around in a circle. Okay, that's a similarity statement. I'll highlight that because that's kind of a vocab word. But you can also talk about similar parts. Similar parts. So this is kind of how we break it down. So angle A is similar to angle W. We're just going to break it down each individual one. The directions in the book, I think, says list all pairs of congruent angles. I guess they're congruent, so we'll mark a little thing underneath. Because angles stay the same no matter what size they are. Angle B is congruent or similar or whatever to angle X. Let's do them all. C to what? Y. And D to Z. So if the instructions ask you to list it all out, that is how you're going to do that. Oh, I like that too, because why not? All right, we have two more things. If they ask you to write a proportion, we can do that as well. If you'll remember from our notes the other day, a proportion is ratios, you set fractions equal, okay? So basically, we're going to look at the sides. Over here on the left, we talked about the angles. Now we're going to talk about the sides. So side AB, okay, side AB is proportional to which side? Tell a partner. Side AB is proportional to which side on the other one? Hopefully you have said WX. AB is proportional to WX on the other side. Okay, really quick. Well, let's just keep going and then I'll show you something. So we're going to say equals and we're going to do another one. BC. BC, tell your partner, is proportional to which other side? XY. Okay, and we keep going. Then CD, again, I'm just going around in a circle. CD is that bottom one. We have to make sure you put it in the right order. So tell your partner which one that one is congruent to. This one you should have said YZ. It has to be YZ. You have to have them in the same place. And then DA, I guess we could say, DA is ZW. Okay? So if they ask you to write a proportion, that's what that means. And the last thing we're going to talk about is called a scale factor. A scale factor. So basically, what's the difference between these two shapes? Like, how much did I stretch it? Let's say I'm starting with the little one. How much bigger did I stretch it? And what we're going to do for that is we're just going to pick one of the pairs. I'll pick AB and WX. Why not? Pick one of them, but you could pick any of them because, as we've said in the proportion, they're all equal. All of the side ratios are equal. And AB side length is 15. And WX side length is 5. Okay, so basically we try to reduce that fraction down, and 15 divided by 5 is 3. So the scale factor is 3, and you always try to put the bigger number on top of the smaller number because you typically like your scale factor to be a whole number and not a fraction. If we would have flipped it over, it would have been 1 over 3. So that is how to do all of that stuff. Whenever we do practice problems, it will ask you to do certain things. So that is what you do whenever they ask you to do certain things. So now we're going to continue on. No really math involved in that one. Just showing you how to set some things up. So now we'll do some math, maybe. Maybe, you know, in math class, it'd be a good idea. All right, so here we have, let me move it down a little bit because we're going to be drawing and stuff. This is example 2, right? Yeah, okay. All right, so here we have a nice, lovely rectangle, A, B, C, D. And we're going to have 2 bigger rectangles. Two bigger rectangles. First one is E, F, G, H. And second one is J, K, L, M. And we're going to label, and then I'll give you the directions of what to do with these. This one is 8 and 10. And obviously this is a rectangle, so the other ones are going to be 8 and 10 as well. But I'm not going to label those. This one's 12 and 14. And this one is 12 and 15. And the directions are: determine which larger rectangle A, B, C, D is similar to. Okay, so it's either going to be, here I'll just say rectangle 1 or rectangle 2. Okay, so we have to determine which one, and we're going to use the scale factor that we just did. So the ratio of the original ABCD is 8, well, I guess we could put 10 over 8, or 8 over 10. Here it doesn't really matter. I'll just do 8 over 10. Sometimes I like to put the little one first. So basically it doesn't really matter. Okay, 8 over 10 is our original one. And so let's see which one is congruent to that. So the first one would be 12 over 14. And over here we have 8 over 10 equals 12 over 15. And we have to see which one is actually congruent. This is a flashback to the notes before when we had to determine if the 2 ratios are congruent. And I did the 1 method, which is divide on a calculator. 2 method is to simplify, reduce the fraction. And the 3rd method is to do the cross multiplication. Either one is fine with me, whatever you want to do. I'm just going to go ahead and I think I'm going to reduce these fractions. All right, so over here, if we divide by 2, we'll have 4 over 5. And over here, if we divide by 2, it is, what, 6 over 7? And those are not congruent. So there's a hint already, but we still have to double check over here. So divide by 2, we already know it's going to be 4 over 5. What can we divide 12 and 15 by? What goes into 12 and 15? How about 3? Divide by 3. It doesn't always have to be the same number, of course. Okay, so 12 divided by 3 is 4, 15 divided by 3 is 5. Oh, look at that. So, but, okay, I did the reducing fraction method, but if you wanted to do the calculator method or the butterfly wings method, you could do that too. Just to get the right answer, you should get it all 3 ways. So, our answer is, I'm going to write a similarity statement. A, B, C, D is similar to, make sure I go in the right order here, J, K, L, M. J, K, L, M. So that is our final answer. It is congruent to, or similar to rectangle number 2, not rectangle number 1. We have one more little example here. We had to throw in some x's to see if we could solve for x, of course. This time I have a weird little shape. That's kind of big, actually. like this, and then up, doop, like that. Oh my, why do these, okay. A, B, C, D. At first it was like A, C, F. I was like, I'm not doing that. So I just redid it. Okay, and the other one is a little bit smaller, and it's also flipped upside down, so they don't always give you the pretty, nice little shape that's the same every time. This one is Y, Z, and then V and W. All right. So this one's going to be a little harder to tell which sides are which, but we can do it. So this is 12, this is 9, and this is X, and this is 10 and 6. Okay, so we want to find X. So this is what we do. X goes with which side? You have to be careful here. X goes with which side? Okay, if we flip that upside down, it's the long bottom side. So the long bottom side on the other one is 10, okay? So X goes with 10. Then we pick one other set of numbers. But 6, so 6 goes with which one? 9 or 12? It's not the slanted side, it's the straight side. So that would be 9. 6 goes with 9. Okay, so you got to match up, basically, X goes with which one, and then pick one other pair of numbers. So here we're going to use the butterfly wing method. Okay, so I'm going to butterfly. Oh my gosh, you know what? We messed up because over here I did the bigger one and then the smaller one. So over here, I need to do the bigger one and the smaller one. Remember? Because they have to be in the same place. And I didn't do that. I put the smaller one on the top. All right, so we said it was 9 and 6. So 9 and 6. There we go. I put 6 over 9. There's my mistake for this video. Always one mistake in all my notes and assignments. All right, so the big one over the smaller one, big one over the smaller one. So now we're ready to go. So I'm going to butterfly wing. 6 times X is 6X. And the other butterfly wing is 9 and 10. 9 times 10 is 90. 9 times 10 is 90. So then divide by 6, divide by 6. And X equals, I believe it is 15. So this is a very important thing that I messed up on that I do not want you to do. Put the same exact shape over the same exact, in the same order, okay? So whenever we do practice problems, you got to remember to do that or else you'll get the wrong answer. We are going to do some practice problems today. I haven't decided what they are, but go see on Schoology what they are and just do them in your notebook. And maybe I'll put the answers online so that you can check yourself, okay? Alrighty, go do that. Have a good weekend.